Welcome to our screencast for solving proportions in an applied problem. So in this lesson, we're going to write and solve proportions in an applied setting, which is just a fancy way of saying word problem. So let's get to it. Before you have a good understanding of this lesson, please make sure that you have a really good understanding of writing proportions. And I did a screencast on that. So you might want to go back and review. And then the reason that we need this is because later on in our math career, we're going to be writing and solving more complex proportions. So we want to make sure that you have a good foundation from this lesson. Okay, so we are going to solve the problem by writing and solving a proportion. And the scenario that we're given is that we're building a scale model of a fishing boat, and it gives us dimensions based off of length and width of the original fishing boat. And we also know something about our model fishing boat. So, and we would like to know how wide it should be. So as we learned in our earlier lesson, there are 8 different correct proportions we can set up. You have to find the one that you're most comfortable with. You need to find the problem solving strategy that makes sense to you. I'm going to try and take you through 2 different ones. So I always start by focusing in on my labels. So for instance, the original information that they gave us was length and width. So that's how I'm going to set up my original proportion. So that's one way of thinking about it. Write the ratio just in the order that you get your information from. So we have original length to original width. And I need to compare that to what's going to be happening in the model. So my second ratio is going to be about the model information, but I do need to make sure that I keep length to width. So my next ratio is going to be the model length to the model width. So that is just this is one way that you can set up your proportion. And then I'm just going to go ahead and substitute my numbers in. Original length to original width is going to be 98 to 35. My model length is 14, and I do not know the width, so I'm going to use a variable. So 98 to 35 is equal to 14 to x. Now we need to go back and rely on our strategies for how do you solve a proportion once you have it in front of you. In this case, the ratio that I wrote has the variable in the denominator. And in general, we want to avoid having variables in denominators. It's not a good habit to get into. So my first step, after I give myself some room to work here, is I'm going to multiply this fraction by x. Because x over x divided by x is 1, so that's going to get rid of that variable in the denominator. But what you do to the right-hand side, you have to do to the left-hand side. So my fractions, so when it simplifies, it's 98/35 x equals 14. Now I need to solve. And if you have a calculator that works with fractions, you could divide both sides by 98/35. But what I'm going to do is use the reciprocal rule. I'm going to multiply my left-hand side times 35 over 98, because 35 divided by 35 is 1, 98 divided by 98 is 1, so that effectively gets rid of my fractions. And if I multiply my left-hand side by 35/98, I have to multiply my right-hand side by 35/98, and I will use my calculator, or knowing my rules of fractions, and 35/98 times 14 is just 5. Now, don't forget, this is a word problem, so x equals 5 is not really how I want our final answer to look. I need to answer the question about how wide should the model be. Well, my label is going to be in inches. That makes sense. So I would say that the model should be 5 inches wide. So make sure on a test or a quiz that you are including the appropriate labels. I think I've said when writing and solving these applied problems, it's all about the label. Okay, let's take a look at our next example. So we're going to solve this problem by writing and solving a proportion. Let's look at Arissa, who used 10 liters of fuel to drive her car 81 kilometers. We're going to assume that her car does everything at the same rate, and we want to know how far can she go with 22 liters of fuel. So a different problem-solving strategy is what I usually use, which is I focus on the question, how far can she go? So in this new scenario or upcoming scenario, I want to know her kilometers, so her new kilometers. And I'm going to compare that to her new liters of fuel. So the way that I am going to set this up, because I know this is going to be my variable, my new kilometers, I want to make that top left. I want to make that the numerator of my first ratio. And you can compare it to the new fuel situation. So if my first ratio is about the new information, then my second ratio has to be about my original information. And again, we need to compare kilometers to fuel. So according to my labels, this is how it's going to look. And then I'm just going to substitute my information. I do not know how many kilometers she's going, but I do know that it takes 22 liters of fuel. The original kilometer she went was 81, and her original fuel usage was 10 liters. So I particularly like this setup better because now I'm really looking at kind of like a one-step equation. What am I doing to the x? I'm dividing by 22. How do we undo divide by 22? Well, I'm going to multiply 22 by, and what you do to the left, you're going to do to the right. And here, again, I'm going to use a calculator, or I'm going to use my strategies for how to multiply a fraction times a whole number. And we're going to get that x equals 178.2. In general, I love fractions, and fractions are the way to go when we're dealing with just what I would call a skill builder problem. But in a word problem, usually decimals are appropriate, especially because we're dealing with money or things like that. So I would say that 178.2 is an absolutely acceptable answer. However, we need to complete our answer. How far can she go? Well, Arissa can drive 178.2 kilometers. So that's just a different strategy of how to approach the problem. Now, again, if you're having trouble writing out an original ratio with labels, I would strongly encourage for you to go back and take a look at writing proportions. You can go back and take a look at that lesson. But if you got it, that's great. And hopefully you have figured out strategies that will help you solve proportions in an applied setting. And that's it for the screencast.